today, in honor of our 75th anniversary of the SOA, we're going to take a look at Eliezer Wright's Arithmeter, which was a computational tool used by actuaries a long time ago to do actuarial mathematics, calculate net premiums, calculate reserves, and enabled actuaries really to do some huge computations, multiplications and divisions. The Arithmeter was invented and patented by Eliezer Wright in 1869. I mean, that's 155 years ago this year. And several of them were made along the way. I think we know of maybe 10 or 15 of these machines that still are in existence. One's in the Smithsonian Institute, but we're pleased to have one of them right here in our SOA Chicago headquarters. Its basic construction is that there are two cylinders here. Both these cylinders have logarithmic scales to them. So you start over here on the left-hand side at 0. The numbering system starts to wind around the cylinder. There's actually about 20 different rows across each of the cylinders. Each of them go from 0 to 10,000. And you can see a little bit here that, the first 1,000, the second 1,000 to 2,000 to 3,000 to 4,000. Eventually, since it's a logarithmic scale, the numbering gets very small as you head towards the end. And what that allows us to do is to use some properties of multiplication, division, and logarithms. The logarithm of two numbers multiplied together is actually the sum of their individual logarithms, and that concept is built into this tool. So when you want to multiply or divide two numbers together, it's as simple as setting one number, holding it constant on this wheel, and then adding or subtracting the next number, whether you want to do a multiplication or division, and then get at the answer by reading across this scale. This is really the predecessor to doing multiplications and divisions in huge spreadsheets along the way that we know today. But by using this contraption, using this machine, I can set one number here and then subtract the logarithm and get a division of another number, and then quickly, within maybe 10-15 seconds, I have what that division would be. There's all these different huge multiplications and divisions that you would need to do to set premiums for a wide range of different maybe underwriting classes and different issue ages. And so doing that longhand would have taken people days, if not weeks, to do. And then if you maybe had a little bit difference in mortality that you wanted to sensitivity test, you got to start all over from scratch and do the divisions all over again. So this tool really was a huge time saver. Of course, today we are very accustomed to setting up all those calculations in a spreadsheet or a computer program, running a macro that spins through all those calculations very quickly. It would only take us seconds in today's mathematics and technology to do, what would have taken weeks by longhand, or maybe just days by using this type of machine back in the late 1800s to early 1900s. What's impressive too is that the numbers from 0 to 10,000 are wrapped around each of these cylinders, one on each side. If you were to take and unwind this numbering system from 0 to 10,000, it's a logarithmic scale, and unwind it, it would literally be over 60 feet long. It would run all the way down an office hallway. And instead, it's wrapped around in about 20 bands here to make it very compact, and also, use the idea of spinning the wheel rather than having to do it in a linear fashion. Just a very huge time saver, almost like the modern technology of a spreadsheet if you had an actuary or an actuarial student who knew how to run this very efficiently. Just a huge time saver for a life insurance company. We see that technology evolving all the time, that actuaries, being their ideas of the mathematics and the pureness of the actuarial science just enhanced by computation tools, whether it's this, whether it's spreadsheets, whether it's computer programs, whether in the future it's artificial intelligence. all a big part of being an actuary. The amazing thing is that even in our example of pricing a product, the basic actuarial mathematics that we're using to do that has not changed over those 155 years.